All right, Mathletes, here's gradients of lines. So remember, gradients are the same thing, and that's synonymous with slope. So a lot of times I'm going to refer to as slope, but slope and gradient of a line is the same. Okay, so when we're talking about slope, we're talking about the angles of these lines. Some of them are steeper than others, some of them are flatter than others, and they go off like this. So what we want to do is mathematically define how these are different and not just say steeper or not so steep. So the equations that we're going to use is the gradient of a line is equal to your vertical step over your horizontal step, or your y step over x, because your y, remember, is up and down. So your rise, okay, and then when we talk about your x step, okay, that's your left and right, or what we can call your run. So a lot of times I'll refer to slope as being rise over run, or your gradient being rise over run. So when we're talking about a positive gradient, if you imagine, if you have a car, okay, and it's moving left to right, okay, so if that car from left to right goes uphill, that is a positive slope, okay, meaning you're having a positive gradient, okay. If from left to right you have a car and it starts going downhill, okay, that is a negative slope. Okay, so positive slopes go up from left to right, and they go down for negative slopes left to right. Okay, so one way we should be able to find gradients is from a graph. So when you're trying to find gradients on a graph, you want to look for lattice points. So these are lattices, so you're looking for when the line passes directly through a lattice point. So here, I'm identifying this as a lattice point. And I'm also looking until I get up here and I notice that this is a lattice point as well. So when I'm trying to define my lattice point, I'm thinking of, to find it, I need to define my change in y. So my rise, I went up 3. And my run is over 2. Okay? So the gradient of this line is 3 over 2. Okay? For part B, okay, again, I'm going to identify lattice points. So I got a lattice point there, and I look until I see a lattice point there. Okay, so my rise over my run. So notice here, I'm going down first. That's a -2. And my run is over 2, 4, 5. Okay, so my slope here, or my gradient, is -2 over 5. And then again, it's a negative gradient because we are going downhill as we go left to right. Horizontal lines, if we think about it, okay, we have lattice points here, we have a lattice point there. Okay, so if we look at this, the rise is 0 over the run of 1. Well, 0 over 1 just is 0. So we say that this has a gradient of 0. Okay, we want to be careful on vertical lines, because vertical lines, we have lattice points there. So the rise is 1, okay, but our run is 0. And we cannot divide by 0 in mathematics. So what we call a slope or a gradient of a vertical line is we say that it's undefined. Okay, so it doesn't have a slope. All right, so if we want to draw a line with a gradient of -2/3 through the point 2, 4, what I want to first do is graph my point. So 2, 4, so I'm going to go over 2 and up 4. So there is the point 2, 4. So now if I want a line with a gradient of -2 over 3, I'm going to start drawing multiple points here. So I can think of this as -2 over 3. So my rise is down 2. Okay, and my run goes over 3. So 1, 2, 3. I have a point there. Okay, and I can do it again. -2, over 3. Okay, so let me erase that there. I have those points and get that point back. Okay, I also want to think about, well, this could be 2 over negative 3. That's the same thing. So I could go a rise of 2 and back 3. So I'm there, rise of 2, back 3. Okay, so as I draw this line, there is a line that's going to connect all these points, okay, that has a gradient of negative 2/3. Okay, it's going downhill from left to right, and it goes through the point 2, 4. Okay, so here, more algebraically, remember that we call our gradient is the change in y, or sometimes we call that delta y over delta x, the change in them, rise over run. So we get this formula. Okay, so if we do y2 minus y1 over x2 minus x1, subtracting numbers gives us the change, so we can calculate the gradient algebraically if we can't graph things. Okay, so you can see from this model here, given any point x1, y1, and y2, x2, to get the height of it, it's going to be y2 minus y1, and the length of it is x2 minus x1. Okay, so let's look at an example here. So the gradient of the line is, find the gradient of the line where it's 3, negative 2, and 6 over 4. So I always just remember rise over run. Rise is your change in y. Your run is your change in x. Okay, so I'm going to call this point here x1, y1. I'm going to call this point here x2, y2. Okay, so y2 minus y1, I'm going to do 4 minus negative 2, y1, over x2, 6 minus 3. I always want to make sure that this lines up with a single point, okay, and the order of this matters, okay, and I want to make sure that these line up with a single point, as they do here, okay, and I have my y values over my x. So now as I simplify it, I get 4 minus a negative is plus 2 over 6 minus 3, which is 3. 4 plus 2 is 6. 6 over 3 can be reduced to 2. So the gradient of my line containing these 2 points is 2. Okay, so here I'm going to kind of backwards solve. I have some unknown t. So I want to find t, given that the line segment joining f negative 2 and 9t has a gradient of 2/3. Okay, so let's call this x1, y1. Let's call this x2, y2. Okay, and that's going to be equal to my gradient. So I already know my gradient is 2/3. What I'm trying to solve for is the t. So change in y. So I'm going to have y2, which is t, minus y1, which is negative 2, okay, over x2, 9, minus 5. Okay, so as I reduce this, I'm going to get t plus 2 over 9 minus 5 is 4, which is equal to 2 over 3. Okay, now I'm using my algebraic solving skills here with rationals. So I'm going to multiply this side by 4, this side by 4. Okay, these will cancel out, and I'm left with t plus 2 here, which is equal to 8 over 3, multiplied by 3, multiplied by 3. These cancel out, and I'm distribute 3t plus 6 is equal to 8. Subtract 6 from both sides, and I get 3t is equal to 2. Divide by 3, divide by 3. So I see that t is equal to 2/3. Okay, So again, remember, this is coming from our equation of y2 minus y1 over x2 minus x1. Define your variables, substitute them into your equation, and then solve it out. That concludes our notes for tonight. Make sure you highlight any questions and bring them to our next class.